Hello, in this lecture we'll answer two questions. On both questions we'll find out the area of a trapezoid. A trapezoid is a quadrilateral with one pair of parallel sides. This is trapezoid ABCD. So it is a quadrilateral because it has four sides, and because of the fact that the opposite sides of this quadrilateral are parallel to each other, that is to say side AB is parallel to side DC, this quadrilateral is defined as a trapezoid. This trapezoid ABCD, the two parallel sides, that is to say AB and DC, are defined as the bases of this trapezoid ABCD. So here the base AB is parallel to the opposite base DC, and if we define the size of the length of side AB as B and the length of side DC as A, then the area of this trapezoid ABCD is equals to the sum of its two opposite bases, that is to say it is A plus B times the height h over 2. So a trapezoid is a quadrilateral with one pair of parallel sides, and the area of trapezoid ABCD is equals to the sum of its two parallel bases, that is to say A plus B times the height h over 2. And the height h is perpendicular to the two parallel bases. Okay, so the area of trapezoid ABCD equals to the sum of its two parallel bases, that is to say A plus B times the height h over 2. So in the first question we find out the area of this trapezoid ABCD. It is given as the question that AB equals to 2 units in its length. Those two angles are right angles. In addition, we know that side BC is equal to side DC. And you also know that the perimeter of this trapezoid ABCD is equal to 16. So what is the perimeter of a trapezoid? The perimeter is the sum of the lengths of all the sides of this trapezoid ABCD. That is to say, the perimeter of this trapezoid ABCD is equal to AB plus AD plus DC plus CB. And you know that the perimeter is equal to 16. So I write it down. The perimeter of this trapezoid ABCD is AB plus AD plus DC plus BC. And you know that is equals to 16. Again, the perimeter of a trapezoid is the sum of the lengths of all the sides of the trapezoid. In this case, it is AB plus AD plus DC plus BC, and you know that the perimeter is equal to 16. So AB plus AD plus DC plus BC is equal to 16. AB is 2 plus AD. We define the length of side AD as A, and we define the length of side DC as B. And because of the fact that according to what's given in the question, DC equals to BC and DC is B, therefore BC must be also equal to B. AD is equal to A units in its length according to our definition. DC equals to B units according to our definition. And BC also equals to B units. So in total it is equals to 16. So Here we subtract 2 from this equation and we get that a plus b is a plus 2b equals to 16 minus 2 is 14. So a plus 2b equals to 14. So here we subtract 2b from this equation and we get that a equals to 14 minus 2b. Again, a equals to 14 minus 2b units in its length. Side AD is equals to a units in its length according to our definition is equal to 14 minus 2b. In the next step, we do a construction. That is to say, from the vertex B of this trapezoid ABCD, we draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. When you find the touching point of the perpendicular from point B and this C, this point is point M. By doing this construction, you get the deal quadrilateral ABMD. Inside this quadrilateral ABMD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4-piece angle, in total it must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this 4-piece angle must be equal to 90 degrees in its size. So inside quadrilateral ABMD we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be at least a right angle if not a square. So we relate to this quadrilateral ABMD is a right angle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABMD, side AB equals to the opposite side DC. Side AB equals to the opposite side DM. But AB is 2, therefore the opposite side DM must be also equal to 2 units in its length. Likewise, according to the same rule, in the same rectangle ABMD, side AD must be equal to the opposite side BM. But AD is 14 minus 2B, therefore the opposite side BM must be also equal to 14 minus 2B units in its length. What is the ref of the missing 97 MC? From the drawing it is very easy to see that MC in total equals to DC minus DM. So write it down, MC equals to DC minus DM. So MC equals to DC. DC is B according to our definition. Minus DM. We just found out that DM equals to 2. So in total, MC equals to B minus 2 units in its length. MC equals to B minus 2 units in its length. In the next step, I'll copy this right triangle BMC in the new page and we will implement the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is a version for Pythagoras theorem. Actually, this is the right triangle BMC that I covered from the original drawing. In this right triangle BMC, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. So I write it down. BC squared, the square of the hypotenuse, is equal to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it is equal to BM squared. BM is 14 minus 2B, therefore BM squared is 14 minus 2B squared. Plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, I should find out that B squared equals to 14 minus 2B squared plus B minus 2 squared. We will open the brackets on this side of this equation and we get that B squared equals to 14 minus 2B squared. 14 minus 2B squared equals to 14 squared, that is 196, plus 2B squared. 2B squared is 4B squared, minus 2 times 14, that is minus 28 times 2B. Minus 28 times 2B is minus 56B. And we have also plus B minus 2 squared. B minus 2 squared equals to B squared plus 2 squared, that is 4, minus 2 times B times 2, that is minus 4B. So here we have B squared on both sides of this equation, so B squared will get cancelled. After cancelled B squared, on this side of this equation we left with nothing, that is to say 0. While on the other side of this equation we have 196 plus 4 is 200. And we also have minus 56B minus 4B, that is minus 60B. And we have also plus 4B squared. So in total, we shall find out that zero equals to 200 minus 60B plus 4B squared. So here we divide this equation by 4. And we get that 4B squared over 4 is B squared. And we have also minus 60B minus 4 is minus 15B. And we have also 200 over 4 is 50. So it is plus 50. It is equals to 0 over 4 is 0. So in total, we should find out that B squared minus 15B plus 50 equals to 0. This is a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, capital A, capital B, and capital C are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that we are looking for is b, or small b. Therefore, x equals to b, or x equals to small b. The coefficients capital A equals to 1. The coefficients capital B equals to minus 15. And finally, the coefficients capital C equals to 50. So the only thing that is left to do is to put this data of our specific quadratic equation in this general formula for x, and in this way we find out the values of small b, because x equals to small b. So we do it now, and we get that x equals to small b, therefore we substitute x by small b. So b equals to minus capital B. Capital B equals to minus 15, so minus capital B is minus 15, that is plus 15 plus minus square root of capital B square. Capital B square is capital B is minus 15, therefore capital B square is minus 15 squared, that is 225, minus 4 times A, minus 4 times A is 1, so minus 4 times 1 is minus 4 times C. C is 50, so minus 4 times 50 is minus 200, divided by 2A. A is 1, so 2 times A is 2 times 1, that is 2. So in total, if you found out that B equals to 15 plus minus, inside the root we have 225 minus 200 is 25, and the square root of 200, the square root of 25, again 225 minus 200 is 25, and the square root of 25 is 5 divided by 2. So here we have two solutions that are possible for B. We define the first solution for B as B1, and the second solution is B2. And we get that the first solution for B is B1, so B1 equals to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So the first solution for B is B1 is equals to 10. The second solution for B is B2, and B2 equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for B is B2, that equals to 5 units in its length. AD is one side of this trapezoid ABCD, and AD equals to A units in its length according to our definition, and A equals to 14 is 2B. So moving on, AD is one side of trapezoid ABCD, and it is equals to A units in its length, and A equals to 14 minus 2B. And 14 minus 2B is the expression for the length of side AD. So 14 minus 2B is the expression for a length. Therefore, the expression for a length, it must be a positive number. What is a positive number? That is to say, it must be greater than 0. So 14 minus 2B must be greater than 0. So here we add 2B to this inequality, and we get that 14 must be greater than 2b. Here we will divide this inequality by 2 and get that 14 over 2 is 7, so 7 is greater than 2b over 2 is b. In total, we should find out that b must be less, b is less than 7 units. From one side, but from the other side, according to the first solution for b 1 equals to 10, that is greater than 7 units. We have a contradiction here because b must be less than 7 units, and according to the first solution, b is greater than 7 units. Due to this contradiction, we cancel this the first solution for b, and we take into account only the second solution for b. The second solution for b is b2 that is equals to 5. b2 equals to 5, that is definitely less than 7 units. So we actually found out that b is equal to 5. That is to say dc is equals to 5, and dc is equals to b according to our definition, and b equals to 5. That is to say dc equals to b and b equals to 5. So dc equals to 5, ab equals to 2, and ad is equals to a is equals to 14 minus 2b. b is 5, so minus 2b is minus 2 times 5, that is minus 10. So a equals to 14 minus 10, that is 4. A equals to 4 units in its length. Our mission is to find out the area of this trapezoid ABCD. And according to the formula that I presented to you in the beginning of the lecture, the area of trapezoid ABCD must be equal to the sum of its two parallel bases. This is actually AB plus DC times the height over 2. The height is AD. Why AD is the height? Because of the fact that it creates 90 degrees with the base AB, and AD also creates 90 degrees with the base DC. Therefore, the height is AD divided by 2. AB is 2 according to what is given as a question, plus DC. We already found out that DC equals to 5. So it is plus 5 times the height AD. The height AD is 4 divided by 2. So in total, we found out that the area of trapezoid ABCD, that is the area that we are looking for in this question, is equal to 2 plus 5 is 7, and 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14. So if we found out that the area of trapezoid ABCD is equal to 14 square units. Repeat again. If we found out that the area of this trapezoid ABCD, is equal to 14 square units. So finish with the first question. The next step, I will present to you the second question, and we will solve the second question of this lecture. In the second question, we have to find out the area of another trapezoid with the same name. This is trapezoid ABCD. It is not the same trapezoid ABCD that we solved in the first question. This is trapezoid ABCD that is a different trapezoid. So in this trapezoid ABCD, you know that side AD equals to 2x units in its length, side BC equals to x units in its length. You know also that line segment AM equals to 3 units, line segment BM equals to 2 units. Those two angles are right angles. This is angle A and B, this is also a right angle. Again, our mission is to find out the area of this trapezoid ABCD. So first of all, we define the size of this angle. Angle BMC is alpha. So in the right small triangle BMC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. DC is one side of trapezoid ABCD, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line DC at point M, here the sum of the angles must be equal to 180 degrees according to rule 3 that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DC at point M? We have this angle that is alpha plus this angle that is 90 degrees plus this missing angle. In total, the sum of those three angles must be equal to 180 degrees according to rule 3. Therefore, this third missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line DC at point M. Exactly according to all three. Therefore, this missing angle must be equal to 90 degrees minus alpha. So in the right big triangle ADM, this angle equals to 90 degrees minus alpha, this angle equals to 90 degrees. Therefore, this third missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. It is the sum of the angles in any triangle. In the next step, we focus on those two right angles. That is to say, we focus on the right big triangle ADM, and in this right small triangle BMC. On those two right angles, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So if we found out that all the angles in the right big triangle ADM are correspondingly equal to all the angles in this small right triangle BMC. And therefore those two right angles are similar to each other according to angle similarity rule. So I write it down. If we found out that this right triangle ADM, the big right triangle ADM, is similar, this is the sign of similar, to the right small triangle BMC, according to angle similarity rule. And from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AD of the big right triangle ADM over side MC of the small right triangle MBC is equal to side DM of the big right triangle ADM over side BC of the small right triangle MBC. And it is also equal to side AM of the big right triangle ADM over side BM of the right small triangle BMC. So repeat again. From the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. That side AD of the big right triangle ADM over side MC of the small right triangle MBC is equal to side DM of the big right triangle ADM over side BC of the small right triangle MBC. And it is also equal to side AM of the big right triangle AMD over side BM of the small right triangle BMC. AD is 2x over MC. MC is the missing side, so we leave it as it is. And it is also equal to DM. DM is the missing side, so we leave it as it is. Over BC. BC is x. And it is also equal to AM, that is 3, over BM, that is 2. So in total, we have found out that two x over MC equals to BC over x equals to 3/2. Those two expressions are equal to each other, therefore we get equation 1 from those two expressions that are equal to each other. So according to equation 1, we get that 2x over MC equals to 3/2. So I write it down. According to equation 1, 2x over MC equals to 3/2. Here we will multiply this equation 1 by MC, and we get that two x equals to 3/2 times MC. Okay, so here we will multiply this equation by 2 and then we will divide it by 3 simultaneously, and we get that MC equals to 2 times 2x over 3. So MC in total, according to equation 1, MC equals to 2 times 2x is 4x over 3. So if we found out that MC equals to 4x over 3 units in its length. This is side MC or line segment MC, and it is equals to 4x over 3 units in its length. So I write it down. MC equals to 4x over 3 units in its length. Those two expressions are also equal to each other, therefore we get equation 2 from those two expressions that are equal to each other. That is to say, according to equation 2, we get that BC over x equals to 3/2. So I write it down. According to equation 2, BC over x equals to 3/2. Here we will multiply this equation 2 by x, and we get that according to equation 2, BC equals to 3/2 times x. Actually, here we have here, it is not BC but DM. Okay, here DM is the missing side, so leave it as it is. So here we have, it is not BC but DM, so it is DM over x equals to 3 halves. Okay, dm over x equals to 3 halves. So according to the second equation, we get that dm over x equals to 3 halves. It's not vc but dm. Yeah, it is dm over x equals to 3 halves. So here we multiply the equation 2 by x, and we found out that dm is not bc but dm equals to 3 halves times x. So according to equation 2, if we found out that dm equals to 3 halves times x. So this is the missing line 7 dm, that equals to 3x over 2 or 3 halves times x. 3 halves times x. Okay. So in the next step, I'll copy this small triangle BMC in the page, and we'll implement the Pythagoras theorem on this small triangle BMC. BC equals to x units in its length. The hypotenuse BM equals to 2 units in its length, according to what is given as the question. And we already found out that side MC equals to 4x over 3 units in its length. So here by PT is a version for Pythagoras theorem. So here, this is the right triangle BMC that the copies from the original drawing. In this right triangle BMC, according to the Pythagoras theorem, BM squared, that is the square of the hypotenuse, equals to BC squared plus MC squared. So I write it down. BM squared, that is the square of the hypotenuse, is equal to BC squared plus MC squared. BM is 2, therefore BM squared is 2 squared, that is 4, and it is equal to BC squared. BC is x, therefore BC squared is x squared, plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. So in total, we found out that 4 equals to x squared plus 4x over 3 squared. So 4 equals to x squared plus 4x over 3 squared. 4x over 3 squared is 4 squared, it is 16, times x squared over 3 squared, that is 9. So in total, we found out that 4 equals to x squared plus 16x squared over 9. So here we multiply x squared by 9 and then we divide it by 9 in order to overcome factor with this expression. And we get that 4 equals to 9x squared over 9 plus 16x squared. 16x squared plus 9x squared is 25x squared over 9. So in total, we found out that 4 equals to 25x squared over 9. So here we multiply this equation by 9, and we get that 25x squared equals to 9 times 4 is 36. So 25x squared equals to 36. Here we will divide this equation by 25. And finally we get that x squared equals to 36 over 25. So x squared equals to 46 over 25. So here we take a root out of this equation. And finally we get that x equals to the square root of 36, that is 6, over square root of 25, that is 5. So in total, if we found out that x equals to 6/5, x equals to 6/5, our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? According to the formula that I presented to you at the beginning of the lecture, the area of this trapezoid ABCD must be equal to the sum of its two parallel bases times the height over 2. The sum of its two parallel bases is of course AD plus BC. Times the height over 2. The height of this trapezoid ABCD is DC. Why DC is the height? Because of the fact that DC creates 90 degrees with the base AD, and DC also creates 90 degrees with the base BC. So the height is DC over 2. So in total, if we found out the area of this trapezoid ABCD is equal to the sum of its two parallel bases, that is actually AD plus BC, times the height DC over 2. AD is 2x plus BC. BC is x times the height DC. DC in total it is 3x over 2 plus 4x over 3. So write it down. DC is 3x over 2 plus 4x over 3. All divided by 2. So in total, if we found out the area of trapezoid ABCD equals to 2x plus x times 3x over 2 plus 4x over 3 divided by 2. So the area of trapezoid ABCD is equal to 2x plus x is 3x, and remember 3x over 2 plus 4x over 3. So here we take 6 as a common factor out of those two expressions, and we take 6 as a common factor by multiplying this expression, the numerator of this expression, by 3, and then we divide it by 3. So 3x over 3 is 9x, and 2 times 3 is 6. Likewise, we multiply the numerator of this expression by 2, and then we will multiply the denominator by 2. So 4x times 2 is 8x, and 3 times 2 is 6. So by doing this operation, we actually created the common factor 6 for those two expressions. So in total, if we found out that the area of trapezoid, and we have to divide it by 2. So in total, if we found out the area of trapezoid ABCD equals to 3x times 9x plus 8x divided by 2 times 6. So it is 3x, and we have inside the brackets 9x plus 8x is 17x divided by 2 times 6. So here we divide both the numerator and the denominator of this expression by 3, and we get that 3x over 3 is x. So in total, in the numerator, we have x times 17x over 6 over 3 is 2. So in total, in the denominator, we have 2 times 2. 2 times 2 is 4. So in total, the area of trapezoid ABCD will be equal to 17 over 4 times x times x. But we have already found out that x equals to 6 fifths. Therefore, we substitute x by 6 fifths. And we get that the area of trapezoid ABCD is equal to 17 over 4 times x. And x is 6 fifths. So we substitute x by 6 fifths. And we have x again. So we substitute x by 6 fifths again. So in total, the area of trapezoid ABCD equals to 17 over 4 times 6 fifths times 6 fifths. So it is 17 over 4. It is 17, and we have here 6 times 6 is 36, and 36 over 4 is 9. So substitute 6 times 6 over 4 by 9, because 6 times 6 over 4 is 9. So in total, the area of trapezoid ABCD equals to 17, and 6 times 6 over 4 is 9, divided by 5 times 5, that is 25. So in total, the area of trapezoid ABCD equals to 17 times 9 over 25. 17 times 9 is 153 over 25. And 123 over 25 is 6.12 square units. So in total, if you found out that the area of this trapezoid ABCD is equal to either 153 over 25 square units, or in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. And that is the answer to the question. Then again, the area of this trapezoid ABCD equals to either 153 over 25 square units, or in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. So we finish with the second question. In the next step, we summarize the lecture. We start with the first question, of course. But before that, what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. This is quadrilateral ABCD. It is a quadrilateral because it has 4 sides, and because of the fact that this quadrilateral ABCD, in this quadrilateral ABCD, side AB is parallel to side DC, therefore this quadrilateral is defined as a trapezoid. The 2 parallel sides, that is to say AB and CD, are defined as the bases of this trapezoid ABCD. Okay? And if we define the length of side AB as B and the length of side DC as A, then the area of this trapezoid ABCD will be equal to the sum of its 2 parallel bases, that is to say A plus B times the height edge over 2. Again, the area of this trapezoid ABCD equals to the sum of its 2 parallel bases, that is actually A plus B times the height edge over 2. The height edge must create 90 degrees with the 2 parallel bases. You can see here that the height edge creates 90 degrees with the base DC, and it also creates 90 degrees with the base AB. So, the trapezoid is a quadrilateral with one pair of parallel sides, and the area of a trapezoid is equal to the sum of its 2 parallel bases, that is actually A plus B times the height edge over 2. So we start with the first question. The first question, our mission is to find out the area of this trapezoid ABCD. It is given as a question that the perimeter of this trapezoid ABCD is 16. What is the perimeter? The perimeter is the sum of the lengths of all the sides of this trapezoid ABCD. That is to say, it is AB plus AD plus DC plus CB. And we know that the perimeter is 16. That is to say, AB plus AD plus DC plus CB is 16. Know that AB is 2. We define the side, the length of side AD is A, and we define the length of side DC is B. And because of the fact that BC equals to CD and CD is B, therefore BC must be also equal to B. So the perimeter of this trapezoid ABCD is 16. That is to say, AB plus AD plus DC plus BC is 16. AB is 2 according to all this given equation, AD is A according to our definition, DC is B, and BC is also B. So in total, A plus 2 plus B is 16. We subtract 2 from this equation, we found out that 16 minus 2 is 14, and A plus B is A plus 2B is 14. Here we subtract 2B from this equation, we found out that A equals to 14 minus 2B. AD is equals to A when it's left, is equals to 14 minus 2B. In the next step, we did the construction, that is to say, from this vertex B, on this trapezoid ABCD, we draw perpendicular on DC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. When you find the touching point of the perpendicular from point B in DC, this point is point M. By doing this construction, we get the quadrangle ABMD. Inside this quadrangle ABMD, we have 1, 2, 3 angles. The sum of 3 angles is 270 degrees, so 270 degrees plus the side of this 450 angle. In total, they must be equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore, this 450 angle must be equal to 90 degrees in its side. So inside quadrangle ABMD, we have 4 angles. And according to rule 5, any quadrangle that has 4 angles must be a rectangle if not a square. So we relate to this quadrangle ABMD, it's a rectangle because it has 4 angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABMD, side AB must be equal to the opposite side DM. But AB is 2, according to what is given as a question, therefore the opposite side DM must be also equal to 2 units in its length. Likewise, according to the symbol, in the sum rectangle ABMD, side AD must be equal to the opposite side BM, but AD is equal to 14 minus 2B, therefore the opposite side BM must be also equal to 14 minus 2B in its length. What is the length of this piece and I say with MC? MC equals to DC minus DM. Again, MC equals to DC minus DM. So MC equals to DC, that is B, minus DM, that is 2. So in total, MC equals to B minus 2 units in its length. The next step, I copied this right diagram BMC in the new page and we implemented the Pythagoras theorem of this right diagram BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. This is the right triangle BMC that are coming from the original drawing. In this right triangle BMC, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and this equals to BM squared. BM is 14 minus 1B, therefore BM squared is 14 minus 2B squared, plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, if we found out that B squared equals to 14 minus 2B squared, plus B minus 2 squared. Open the bracket on this side of this equation, and finally found out that B squared equals to 14 minus 2B squared. 14 minus 2B squared equals to 14 squared, that is 196, plus 2B squared. 2B squared is 4B squared, plus B minus 2 squared. B minus 2 squared equals to B squared, plus 2 squared, that is 4, plus 2 times B times 2, that is minus 4B. Here we have B squared on both sides of this equation, so B squared will get cancelled. After we cancel B squared, in this side of the equation we have nothing, that is to say 0. While on the other side of this equation we have 196 plus 4, that is 200. We also have minus 56B minus 4B, that is minus 16B. And we have also plus 4B squared. So in total, from the equation, we have found out that 0 equals to 200 minus 60b plus 4b squared. Here we divided this equation by 4. Finally found out that 4b squared over 4 is b squared, and we have minus 60b over 4 is minus 15b, and we have 200 over 4 is 50, and 0 over 4 is 0. So in total we can found out that b squared minus 15b plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, capital A, capital B, and capital C are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we found out the value of x, and according to the following formula, x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that you are looking for is small b. So x equals to small b, the coefficient a equals to 1, the coefficient b equals to minus 15, and the coefficient c equals to 50. So the only thing that is left to do is to put this data of our specific quadratic equation inside this formula for us, and in this way we find out the value of the values of small b, because x equals to small b. So we did it, and we found out that x equals to small b, so we substitute x by small b, and we found out that small b equals to minus b. B is minus 15, therefore minus b is minus 15, that is plus 15, plus minus square root of b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225, minus 4 times a times c. So it is minus 4 times a is 1, so minus 4 times 1 is minus 4 times c is 50, so minus 4 times 50 is minus 200. So inside the brackets we have 225 minus 200, that is 25, and the square root of 25 is 5. And here we have also over 2a. A is 1, so 2a is 2 times 1, that is 2. The square root of 25 is 5. So in total we should found out that b equals to 15 plus minus 5 over 2. So here we have two solutions that are possible for b. And we find the first solution is b1, and the second solution is b2. So the first solution for b is b1, and b1 equals to b1 equals to 15 plus 5 over 2. 15 plus 5 is 20, and 20 over 2 is 10. So the first solution for b is b1, that is 10. And the second solution for b is b2. b2 equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b is b2, that is 5. And the first solution is b1, that is 10. AD is one side of trapezoid ABCD, and we find the length of side AD is A, and A equals to 14 minus 2B. So AD equals to A, and A equals to 14 minus 2B units in its length. So 14 minus 2B is the expression for the length of AD. And the length must be a positive number. So for this expression, that is the expression for the length, it must be a positive number. What is a positive number? That is to say, it must be greater than 0. Therefore, 14 minus 2b is greater than 0. So we needed to be to this inequality. We finally found out that 14 is greater than 2b. We divided this inequality by 2. And finally found out that 14 over 2 is 7. And it is greater than 2b over 2 is b. So in total we should found out that b must be less than 7 units from one side, but from the other side, according to the first solution, b is equal to 10, that is greater than 7. 10 is greater than 7 from one side, but b must be less than 7. So we have a contradiction, and due to the contradiction, we consider this first solution for B, and we take into account only the second solution for B, that is B equals to 5. So DC equals to B according to our definition, and B equals to 5. So DC equals to 5, AB equals to 2, and AD equals to 14 minus 2B. B is 5, so minus 2B is minus 2 times 5, that is minus 10. So in total, A equals to 14 minus 10, that is 4. So AD is 4. Our mission is to find out the area of this trapezoid ABCD. According to the formula that I presented to you in the beginning of the lecture, the area of this trapezoid ABCD must be equal to the sum of its two parallel bases, that is actually 8B plus DC, times the height AD over 2. And again, the area of trapezoid ABCD must be equal to the sum of its two parallel bases, that is actually AB plus DC, times the height AD over 2. AB is 2, DC is 5, AD is 4, divided by 2. 2 plus 5 is 7, and 4 over 2 is 2. So in total, this expression equals to 7 times 2, that is 14. So if you found out the area of this trapezoid ABCD equal to 14 square meters. We finish with the first question. In the next step, I present to you the second question, and we solve the second question of this lecture. The second question, we have to find out the area of another trapezoid with the same name, trapezoid ABCD. Again, the second question, we have to find out the area of another trapezoid with the same name, trapezoid ABCD. So in the domain, we have trapezoid ABCD. Side AD equals to 2x units in its length, side BC equals to x units in its length. This is 970 AM, that is equal to 3 units. This is 970 PM, that is equals to 2 units in its length. Those two angles are right angles. This is angle A and B, this is also a right angle. Again, our mission is to find out the area of this trapezoid ABCD. In the first step, we define the size of this angle BMC as alpha. So in the right small angle BMC, this angle equals to alpha, this angle equals to 90 degrees. Therefore, this first angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. It is the sum of the angles in an angle. DC is one side of trapezoid ABCD, therefore this is absolutely a straight line. So if you focus on the upper side of the straight line DC at point M, here the sum of the angles must be equal to 180 degrees according to rule 3 that says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of DC at point M? We have this angle that is alpha, plus this angle that is 90 degrees, plus this missing angle. In total, the sum of those three angles must be equal to 180 degrees according to rule 3. Therefore, this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees. 90 degrees plus 90 degrees, it is equal to 180 degrees. It is the sum of the angles of the upper side of DC at point M, according to rule 3. Therefore, this missing angle must be equal to 90 degrees minus alpha. Again, 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. It is the sum of the angles on the upper side of DC at point M according to rule 3. Therefore, this missing angle must be equal to 90 degrees minus alpha. So in the right big triangle ADM, this angle equals to 90 degrees minus alpha. This angle equals to 90 degrees. Therefore, this third missing angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees it is equal to 180 degrees. It is the sum of the angles in a triangle. Therefore, this third missing angle must be equal to alpha. In the next step, we focus on those two right angles. This is to say, we focus on the big right triangle ADM and the small right triangle BCM. And we prove that those two right triangles are similar to each other according to angle similar to 1. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So in total, we found out that all the fingers of the big right triangle ADM are correspondingly equal to all the fingers of this small right triangle BCM. And therefore, those two right triangles are similar to each other according to angle similarity rule. So I said again, I found out that the big right triangle ADM is similar. This is the design of similar to the small right triangle BMC according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive the side AD of the big right triangle ADM or side MC of the small right triangle BMC is equal to DM. This is in the big right triangle ADM or side BC of the small right triangle BCM, and it is also equals to AM of the big right triangle ADM or BM of the small right triangle BMC. Then again, from the fact that those two right triangles are similar to each other, we derive that AD or MC equals to DM over BC equals to AM over BM. AD is 2x, MC is the missing signs of relative cities, DM is the missing signs of relative cities, over BC, BC is x, and AM is 3, and BM is 2. So in total, we found out that 2x over MC equals to DM over x, and it is also equals to 3 over 2. Those two expressions are equal to each other, therefore we get the equation form from those two expressions that are equal to each other. That is to say, according to equation 1, 2x over MC equals to 3 halves. Again, according to equation 1, 2x over MC equals to 3 halves. If we multiply this equation 1 by MC, and finally found out that 2x equals to 3 halves times MC. If we multiply this equation by 2 and then we divide it by 3 simultaneously, and finally found out that MC equals to 2 times 2x over 3. 2 times 2x is 4x, and so in total this expression equals to 4x over 3. So in total we found out that MC equals to 4x over 3. This is 97 MC, that is equals to 4x over 3 units in its length. Likewise, those two expressions are also equal to each other, therefore we get equation 2 from those two expressions that are equal to each other. That is to say, according to equation 2, BM over x equals to 3 halves. Again, according to equation 2, dm over x equals to 3 halves. But again, according to equation 2, dm over x equals to 3 halves. If we multiply this equation by 2, and finally found out that dm equals to 3 halves times x. So according to equation 2, we found out that this is the answer when dm is equals to 3 halves times x. The next time I comment this small right triangle BMC in the new page, and we implemented the Pythagoras theorem in this small right triangle BMC. So actually, this is the small right triangle BMC that I covered from the original moment. This small right triangle BMC, BM squared, that is the square of the hypotenuse, equals to BC squared plus CM squared. BM is 2, therefore BM squared is 2 squared, that is 4, and is equals to BC squared. BC is x, therefore BC squared is x squared, plus MC squared. MC is 4x over 3, therefore MC squared is 4x over 3 squared. So in total, we found out that 4 equals to x squared plus 4x over 3 squared. 4x over 3 squared equals to 4 squared, that is 16, times x squared over 3 squared, that is 9. So in total, 4x over 3 squared equals to 16x squared over 9. So for the next time we multiplied x squared by 9, and then we divided by 9 in order to a common factor with this expression. And we actually found out that 4 equals to 9x squared over 9 plus 16x squared over 9. 9x squared plus 16x squared is 25x squared over 9. So in total, we actually found out that 4 equals to 25x squared over 9. We multiplied this equation by 9 and finally found out that 25x squared equals to 4 times 9, that's 36. So 25x squared equals to 36. Here we divided this equation by 25 and finally found out that x squared equals to 36 over 25. So here we took out all of this equation and finally found out that x equals to the square root of 36, that is 6, over square root of 25, that is 5. So in total, we found out that x equals to 6 fifths. Again, x equals to 6 fifths. Our mission is to find out the area of this trapezoid ABCD. So according to the formula that I presented to you at the beginning of the lecture, the area of this trapezoid must be equal to the sum of its two parallel bases, that is actually AD plus BC, times the height, that is DC over 2. So again, the area of the trapezoid ABCD must be equal to the sum of its two parallel bases, that is actually AD plus BC, times the height CD over 2. AD is 2x, BC is x, and CD in total equals to 3x over 2 plus 4x over 3. Again, CD in total equals to 3x over 2 plus 4x over 3. Divided by 2. 2x plus x is 3x. And we have here two expressions, 3x over 2 plus 4x over 3. Actually, took out 6 as a ground factor out of those two expressions. We did it in the following method by multiplying both the numerator and the denominator of this expression by 3. 3x times 3 is 9x, and 2 times 3 is 6. So this expression in total equals to 9x over 6. Likewise, we multiplied 4x over 3, the numerator of 4x over 3 by 2, and then we multiplied the denominator by 2. So 4x times 2 is 8x, and 3 times 2 is 6. So in total, we have found out that 3x times 9x plus 8x over 6 times 2 equals to the area of trapezoid ABCD. 9x plus 8x is 17x. So in total, in the numerator we have 3x times 17x over 2 times 6. We divided both the numerator and the denominator of this expression by 3. 3x over 3 is x. So in total, in the numerator we left only with x times 17x, and in the denominator we have 6 over 3 is 2. So in total, the denominator we left only with 2 times 2. So in total, we have found out that x times 17x over 2 times 2 is the area of trapezoid ABCD. 2 times 2 is 4, and the numerator we have 17 times x times x. So in total, the area of trapezoid ABCD equals to 17 over 4 times x times x. But we have already found out that x equals to 6/5, so substitute x by 6/5. So the area of trapezoid ABCD in total equals to 17 over 4 times x, and x is 6/5, and you have x again, that is 6/5 again. So in total, the area of trapezoid ABCD equals to 17 over 4 times 6/5 times 6/5. 6 times 6 is 36, and 36 over 4 is 9. So we substitute 6 times 6 over 4 by 9, because 6 times 6 over 4 is 9. So in total, in the numerator we left only with 17 times 9 over 5 times 5, that is 25, plus 4 that's cancelled. So in total, the area of trapezoid ABCD equals to 17 times 9, that is 17 times 5 over 25. 17 times 9 is 153 over 25. 153 over 25 is 6.12. So in total, if you found out the area of this trapezoid ABCD, the area that we are looking for this question equals to either 153 over 25 square units, so in terms of numbers, the area of this trapezoid ABCD is equal to 6.12 square units. Okay, thank you very much.